Welcome to the February meeting. We have some great things tonight, but I'm going to start things off really quick with a pretty cool little message to everybody here. You all saw some pictures not too long ago about when I did it. Well, here you all go. Hey, Geology Club members, Dirtman here, and I'm at the Baltimore Arena as a metaphor to tell you that the leadership team has not stopped working for you all winter long. And you know what? Big things are going to happen in 2026. So stay tuned. It's going to be awesome. All right, I hope that pumps everyone up there. Happy to bring you so much in 2026. We have so many trips planned for you. Vanessa has been going on overload, booking them like every weekend. We're still trying to get a lot of these down and finalized for everyone. So we're not going to tell you exactly everything, but I've got a lot of things to show you, which is cool for places we're going to go this year in the next couple slides. So on behalf of the leadership team, give me 1 second. Let's get back to the slides here. So on behalf of Tina, Joe, and myself, and then of course our team, Sylvia, Vanessa, Joanna, and Michael, we all welcome you to the February meeting. Thank you all for being here. It's going to be really good with Brittany. She's got a great presentation tonight. I also have a Dirtman Report. But let's get into some announcements. We still have 2 positions that we are looking for. We'd like membership members to step up, and if you are interested in being a secretary or youth leadership leader, we would like to talk to you and see what you got. We want, motivated, energetic people. We have a great team right now going on. We have a lot of people, willing to do a lot of great things in 2026, and we're very excited. So, like the video said, we haven't stopped all winter. We've been planning and working on stuff, and it's all coming together. So, going to be a great year. Events, just a few right off the bat. Of course, March 7th, I want everyone to come out to Harrisburg, Lingelstown, Central PA's Rocks for Kids. I'm going to be there demonstrating gold. Usually we let, each kid walk away with a piece of gold if they can pan it out. But, gold is now $5,000 an ounce or something like that. So it would be very, very crazy to pay for all that gold for kids. It'd be so expensive. So I'm going to go back to demonstrating it. We did that in the past, back in, COVID times. So it's great, still great. We're going to have so many other vendors, not vendors, tables set up with lots of activities for kids. Of course, we're also going to have the trilobites. My trilobite decorating are going to be there, but you're going to learn about fluorescence. There's going to be a fluorescent tent. Rich Casey is on tonight. I think he's going to be running that. There's going to be all kinds of fossil demonstrations and learning about rocks. And of course, there's always the sales table. You can always pick up a few really good things there. Now, unfortunately, the same weekend every year is always the DMS show. However, you can always go on Sunday. So you come out Saturday to the Rocks for Kids. You go out on Sunday to the DMS out in Delaware. That's a great show. That is a big show out there. So very good spot to pick up some deals as well. But here's one thing that we are working on here at Geology Club. Last year, I went and visited a very good friend out in Dillsburg, right on the Triassic. So we're talking with Dr. Jen Patea. I was just with her on Saturday up at the Montour Preserve event. And we're talking about maybe doing a kids event, doing a whole thing on dinosaurs and gold, because there's gold in that stream too. So there's a stream there, there's a pavilion. We might do some kind of big old kid thing. So we're still putting this together, but I wanted to get that out to you because me personally, I'm kind of excited about it because Dillsburg dinosaurs, they weren't actually dinosaurs, they were more reptiles, but we're getting there. Field trips. So these are all the ones that I was talking about. These are still being set. We don't have an exact date, so I didn't want to just put them out there, except I wanted to tell you. So we are going to get into the Texas Maryland quarry. This is the same quarry that I believe part of the Washington Monument came out of. The actual marble for it came out of this quarry. And for me personally, it is very near and dear to my heart. I drive by it every single day on the way to the studio here in Baltimore City from Pennsylvania. And my great grandfather actually used to haul rock in that quarry back in the day. So we're also going to go, of course, New Paris Quarry. We'll do that with Central PA. Rock and Mineral Club, number 9 Coal Mine Tour, Sterling Hill, Diamond Mountain, of course, up in New York, along with all the other Mohawk Valley Mineral Mining and Area 52 as well. We're also going to still try to get into U.S. Silica, Berkeley Springs. Still talking with Professor Steve Lindbergh about that. Keeping my fingers crossed that we're still going to get into there. That is a sand plant with quartz crystals. So love to get in there. It'd be great. Here's what you know. Fossils and hot chocolate. We had that scheduled. It dumped snow. So we're hoping to get that first weekend of March or something like that. We're going to get that on the books as soon as possible. So like the bottom of this page says, watch your email. Saturday, May 2nd, National Limestone. Everyone's always looking for National Limestone. So here we go. Hewitt Gem Mine, May 17th. We're doing that with Central PA. Also, that is their trip. We're going to tag along with that. So what was good about that date was May 17th is the weekend before we're going to do the Memorial Day weekend trip up to Mohawk and Area 52. So if you want to tie those two together, we also left the weekend in between May 2nd and May 17th because we're hoping, fingers crossed, we're hoping somewhere in there we're going to get to the Amish Amethyst Field out in Lancaster. So we're trying to keep things fluid, make sure we can get out there as well. So yes, Memorial Day weekend, Area 52, Mohawk Valley Mineral Mining. Lottery starts in April. We are not going to run it early. We want to make sure everyone knows about it. We'll get in. We're going to have at least 35 people be able to go on that trip. And then we're going to have another one in Labor Day, later in the year. So those who get to go on the Memorial Day weekend trip will not be able to go on the second trip. We're going to try to keep things fair so that people that, miss out on the first trip get to go on the second trip, have chances to go on, get in and win the lottery on the second trip. And of course, going on from there, we will be going back in future years. As long as no one does anything stupid while we're there. And of course you won't. I know everyone won't. We'll be awesome. It's a great place. And of course, those who don't win the lottery, Mohawk is open for everyone. And I will be there as well. I'm going to be back and forth to make sure that everyone is okay on both sides of the Mohawk River. So great stuff going on. So to keep on going with Area 52, just so people know, yes, limited attendance. When you do win the lottery drawing and you get to go, it's going to be $50 per day per person. However, there's also a porta potty fee. It doesn't matter if you don't want to use the porta potty. It's all, everyone's got to take a small portion. It's only going to be a few bucks, but everyone's got to chip in. I don't have that rate yet. That's coming from the owner of Area 52. He's figuring that out now, because there are 5 other clubs getting in. Well, no, we are one of 5 clubs, so there are 4 other clubs. There's always 2 that have always gotten in there, and that's the 2 New Jersey clubs. That's because Ryan Klockner, he's friends with Shane too. So um, the third, I think, is a Long Island club. I can't remember. So and there's a fourth. So I'm not sure who the other 2 are, but that's going to be announced very soon. But we will be one, and they've been actively promoting us on their auctions. I've been on it to provide, backup with, websites and stuff if they want to join our club and all that. So that's been great. And that's how I got a lot of these crystals for us to raffle off, came from those auctions. There will be camping on site. This is, primitive, no power, no water. This is just a field. So as opposed to Mohawk, this isn't a cliff. This is kind of top down digging. We will be in a field, and there's plenty of other diggings that have already been there. So there's already kind of a little shelf that you can get into. But for the most part, this is a bit different. And this is a private mine. It's own clubs getting in here. And for the rest of the year, it's just the owner and his team pulling out crystals for the auctions and stuff. So here's the big thing. Power tools are okay. So, as opposed to the other mines out there, power tools, bring them. You just don't have power. So, they got to be battery powered, something like that. So here we go, everybody. Let's do it. Raffle. So let me stop sharing so I can show off the crystals. But before I do so, enter a number into the comments, 1 to 350. No duplicates. If you enter a number that's already been in the comments, you got to choose another one and re-enter it. No one can have the same number twice. Drawing will be after the presentation. So these are the crystals. Let me stop sharing. I will shove them into the camera here. So I was kind of showing them off right before. That is one end. You can see the facets, hopefully. Anyway, this is all faceted. It is one large kind of crystal. It has a damage right, on the, sort of right here on the back here. That's damaged, but it does have 2 points. Sorry, I keep on going the wrong way. It's backwards for me, but there's 2 points there. And then the point down here at the bottom. So that's one crystal. You will get that. And then this, what Shane, the owner, always calls it a hawk nose. He's known for that, but it is a double terminated, sort of clear, kind of tabby, but that's the other one. That's the smaller one. So those are both from the Area 52 auctions. So those who haven't already, put in number 1 to 350. I don't even have my chat window up, so I haven't been paying attention. I will go through that in a minute. So go for it. I will send this out free of charge. You will get a box. You will actually get the crystals in a burlap sack, in a box like this. This is in this box, and I will send that out to you free of charge. I just need your name. So if you have a weird name on the participants list, I'm going to ask you for your name if you win it. And then I'll have your address after that. So, all right, let's get on with it. Here we go, everybody. Myrtle Beach Impact Craters. So this was my 4th Dirtman Report ever. I filmed it. I wrote it, filmed it, edited it, and then released it all within, from a Thursday night to a Tuesday night. So all of this is based on a book. There's a lot of facts behind this. I hope you all enjoy. It now has music and graphics and stuff like that, but this ties directly into our presentation tonight, our main feature, because you'll see. It's going to be very interesting. Here we go.
Dirtman here with another special report, this time from Myrtle Beach, South Carolina, where you can find lots of fossils just like covered cliffs, shark's teeth, stingray teeth, but one thing you're not going to find here, rocks. That's actually why I'm here. So let's go inland, check something out. This is the real geological story. That little raised ridge back there, only a few feet high, actually the edge of an impact crater from 12,900 years ago, what scientists believe caused mass extinctions and the start of the Younger Dryas period. But to really see how big of a story this is, I need to take you up there.
So I found the best pilot in town at Helicopter Adventures to fly me up the Carolina Bays Parkway, which is named after these impacts. Yet, amazingly, no one I met and talked to here has ever heard anything about any impact craters. But then, there they were, two craters overlapping in the distance. And here, this half-moon shape. And these sandy areas are overturned flaps, debris ejected from these impacts. However, to see the true scale of these impacts, we need to go even higher. This is a Google Earth image of the Myrtle Beach area. There are over 60 visible Carolina Bay impact sites just in this one area, but we still need to go even further up to see everything. This is a LiDAR image from Tatum, South Carolina. Just like the Google image, all the Carolina Bays point the same direction. However, in Nebraska, the same impacts can be found, but aligned differently. Both sites point to where scientists say a comet struck the Laurentide ice sheet, sending massive ice boulders into the atmosphere and creating these sites 10 minutes later when they rained back down, destroying everything in their path. There are no bays on rocky ground. Only sandy soil close to the water table can be liquefied on impact. Then, through viscous relaxation, refills exactly as it was, only leaving raised edges and flaps, like this one, still here after 12,900 years.
So the next time you're in Myrtle Beach, don't hit the beach. Go inland, check out some real history. I'm Dirtman, and this is my special report.
All right, everybody. I hope y'all enjoyed that. So basically, we were coming out of the last glacial maximum and things were starting to melt. But then along comes this comet, and scientists say, not all scientists, because this isn't mainstream science, this is kind of fringe, but it's accepted by a lot of people. This comet hit the ice sheet, during the melt. So Brittany will touch on some of this. And there was also, this Lake Agassiz that released all of its water and changed things too. So a lot of things happened right around this time, which caused, the Younger Dryas period, which is when we went back into another glacial period for 1,000 or so years, and then came back out, to our normal temperatures. So I'm going to not say anything more about that because I'm stepping on Brittany's toes. But before I want to introduce her, because out of everyone that we've had here on the Geology Club meetings over the past year, I've respected them all. I will tell you all right now, I respect Brittany more. She has helped me become who I am in the geological world more than a lot of people. She holds a very special place, in my opinion, and not to mention my political being president of the EFMLS would not have happened if I wasn't Central PA's president, and it wouldn't have happened if it wasn't Brittany helping me become Central PA's president, because I followed in her footsteps and she helped me the whole way. So not only politically, but geologically, I turn the floor over to one of the most knowledgeable, helpful, one of the best people out there, Brittany Martin.
Well, thank you. That was very kind words, and I appreciate it very, very much. Yeah, Andrew came into Central Penn as a newbie, and we threw him right into things. And as you can tell, he hasn't stopped. And now here we are at Geology Club. So I'll go ahead and start sharing for those of you. And yes, he did bring up Rocks for Kids, and I want to say about Rocks for Kids, it's a great event. I got a little sore throat starting, but we're gonna get through this. I don't do any demonstrations or run any of the tables there. I work registration because I think anyone who knows me knows you're not going to get me to sit still at one station for 5 hours. So you'll see me at the registration table. I'm going to go. All right. So for those of you that don't know me, I grew up in Northwest Ohio, and I think I got my screen share things that I was supposed to. Nope, I didn't. There we go. Got my bachelor's in environmental science, and then I went on to get a master's in geology. I worked as a geoscientist for about a decade, and now I sell my rocks and minerals, and I also teach earth science for a charter school. So good stuff. I'm getting there, guys. There we go. Alrighty. So one of my favorite, this is my absolute favorite talk to give. I'm just going to minimize this so I only see, I get distracted by the little boxes. Okay, this is one of my favorite talks to give because of what I did my research on when I was in school, which I'll cover just a little bit. But I want to get to the good stuff, which is glaciers and glacial landforms. This is where my passion lies. So what is a glacier? Well, it's a large natural accumulation of land ice affected by present or past flowage. A glacier is a slowly flowing mass of ice with incredible erosive capabilities. I probably say it in every talk that I give that water is the most, in any form, is the most powerful thing that we have on Earth. It's shaped many landforms. Glacial ice sheets affect our climate by reflecting sunlight. They affect our global heat transport, and they also affect sea level to a certain extent. But we want to know, how does a glacier form? Well, glacier ice is going to build up when snowfall in winter exceeds snow melt in the summer. That makes sense. Each annual layer of snow is going to melt and refreeze and form ice. And it's kind of, think about it as sedimentary rocks forming. You have deposition on top of deposition on top of deposition, and all of that extra weight and pressure is going to continue to compress and cement and liquefy. The same thing's happening to this ice. And after about 2 years, you have what we call firn. And it takes almost five to 6 years before you have real glacial ice. And in 10 years, that's when we're starting to get our big glacial ice sheets. So there are two types of glaciated terrains on Earth. We have our alpine glaciations, and these are the ones that form in the mountains. And then we have our continental glaciations. These are the ones that cover our continents, like the Laurentide ice sheet that Andrew was just talking about in his video. These are the ones that allow accumulated snow to persist from year to year. I'm going to go ahead and start with the alpine glaciers. They make some pretty awesome landforms. So here's what a alpine system would look like when it's all filled in with the glacial ice. And then here on the right is what it's going to look like after all that glacial ice is gone. Obviously, this is kind of exaggerating, but to get to the point that we have a lot of different types of landforms that have been left behind. So here's the slide that you're going to see on all my slides when I'm talking about it, just to give you a reference of the ones that we're going to go over. And I'm going to start with the glacial trough, the big one. This is the deep-sided rock trench that's formed by an alpine glacier erosion. So this whole valley was filled with ice. As you can see, if you have a U-shaped valley, it's going to be carved by a glacier. If it's formed by a river, it's going to be a V-shape. So you see a V-shaped valley, you can say river. You have a U-shaped valley, you can say glacier. Here's a picture from Rocky Mountain National Park. I have a lot of pictures from there because I was lucky enough to enjoy this park. This whole area you can see, hopefully you guys can see my arrow. This is the first time I'm giving this talk over Zoom. So you can see the—
we can see it. We can see it.
Okay, great. So here's the U-shaped valley here. Everything you see in the distance is all filled with ice at one point. And here you can see this is the extent of that glacial ice. So as it melted away, it took all of this rock with it. It plucked it away. Same here. You see this U shape here? All of this was plucked out and carried out by the glacier when it receded. So this is a cirque. This is a valley head enlarged and hollowed out by glaciers, which produce bowl-shaped valleys. So what this is, all the ice was filled in here, and it's traveling up and growing and growing and growing until it grew up into here. So here's the extent of the ice in this alpine situation. And as it eroded and receded out, again, plucked and took all of this rock debris with it and left this bowl-shaped cirque. And if you notice right here in the middle, we have a little extra gouging that took place. And what that is a tarn, a small lake occupying a rock basin within a cirque. And that's what you see here. So this is Bear Lake at Glacial National Park. This is all filled in with ice. And here we go up here. See, U-shaped valley here, U here. Ice went into here and into here, and it scooped out this bowl cirque here. This right here along the edge, this is another glacial feature we're going to talk about. Oh my goodness, so here's me 20 years ago thinking I'm so cool with my Brunt compass on my hip, but notice the cirques in the back. So this whole glacial valley that you see that I'm standing in, completely filled with ice, way above my head by hundreds of feet. But the ice happened to stretch out just a little bit further. You can see it going up right here and up right here and gouging all this out before it receded. And there we go. I pointed out the arête. These are narrow ridges of rock that separate two valleys. It's typically formed when two glaciers erode parallel U-shaped valleys. Again, with that U shape. So here's our arête. We would have had glacial ice coming up here and glacial ice on this side too. So the glacial ice didn't quite make it up to meet together. So we end up with these arêtes. Horn. This picture you probably recognize as the Great Matterhorn. This is a steep-sided peak formed by glacial erosion from three sides. So a horn is going to be three sides. And here, I tried to zoom it up a little bit. Here is our local horn at Rocky Mountain National Park. You can only see the two sides here. One side is here, one side's here. There's another side here. Here's the arête coming down, our U-shaped valley. All this filled with ice. A col, this is a natural pass or low notch in an arête between opposed cirques. So we're really getting crazy now because we got a cirque over here on the left. Here's our arête. And here's the erosion that took place in the arête and the arête. And then there's a cirque on the other side. So it's like cirque, arête, col, arête, cirque. We got names for everything. A hanging valley. This is a valley carved out by a small tributary glacier that is going to join with the big glacier. So the big glacier is where that waterfall is falling into. That's where all that's the big ice. And then that hanging valley, that's just where some ice shot up and carved its own little U-shaped valley. And it is really neat how they do tend to have these beautiful waterfalls associated with them. Here's a hanging valley at Rocky Mountain National Park. Again, not quite perfectly U-shaped, but you see it there. Next, we have the Paternoster Lakes. These occur in a series down a formerly glaciated valley in small basins. So this is all covered with ice all the way up to here. It's starting to retreat and it kind of stalls here. And then kind of, it's working things up because the ice is actually always moving. It never actually stops moving, even though it's stalling. It's moving within itself. So it's scooping this stuff out. It's going to retreat, recede back a little further. It kind of stalls here again, recedes back again, and it stalls again. So you end up with these series of step-down lakes called Paternoster Lakes, and they represent areas that the glacier stalled. A fjord. We know fjords, narrow, deep ocean inlets, partially filling a glacial trough. Absolutely gorgeous things, we know that. Moraines. So this is a lot. You think of moraines and moraine? Well, of course we got several types of moraines, right? We're scientists. So let's just go to the figure because that's a little easier. Starting over on your right, we have the terminal moraine. So this not only represents where the glacier stopped, this represents the furthest extent that the glacier went. These ground moraines represent when the glacier was advancing and it stopped, but it had further to go. It wasn't quite done advancing. And then you have recessional moraines where a glacier will stall as it's receding. You have your lateral moraines, which will build up along the sides of the glaciers. And you have your medial moraines, and those are where two glaciers join together. And then your outwash plain. This is just meltwater is washing out all the stuff the glaciers picked up along the way and plucked up. And finally, you have to look real hard these days in Rocky Mountain National Park to find a glacier. But I did it. This little itty bitty glacier was found. Alrighty, moving on to ice sheets and the continental ice sheets. So we have two presently. We know them. They're Antarctica and Greenland. Those are our current ice sheets. And from those, we get sea ice and icebergs. Sea ice is floating ice of oceans formed by direct freezing of ocean water. They're always less than 5 meters thick to be qualified as sea ice. Pack ice is sea ice that completely covers the sea surface. And we also have what's called ice floes. These are individual patches of sea ice floating about. Icebergs, these are mass of glacial ice floating into the ocean that is broken off of a glacier. That's known as calving when you see those videos of the ice falling off into the water and causing the waves. They can be hundreds of meters thick. And remember that what you see is only about 90% of the iceberg, or 10% of the iceberg. 90% of that iceberg is actually underwater. And they're always composed of fresh water because they're composed of glacial ice. Some landforms made by ice sheets. This is just as they're moving along, they can scratch that regolith off, which is all the loose material that's on top of the bedrock. It's going to abrade and take that away. The ice can abrade the bedrock. Kelly's Island in Lake Erie, those are supposed to be glacial grooves. I actually did a study in college that kind of suggested that they were formed by flowing water. So that was an interesting study to take part in. So again, we're going back to, let's see here. Let's go to the ice sheet that we know, the Laurentide ice sheet. Our last glaciation was the Wisconsin glaciation. This was the last major stage of the ice age in North America. So here's a picture of kind of the extent of the Laurentide ice sheet. And I wanted to throw the, the picture of Ohio in just because this is where I kind of grew up here, where they had to drain the swamp. So geology growing up for me wasn't mountains, it wasn't wave of light, it wasn't crystals, it was till. It was till, sand and rounded rocks and that kind of stuff. Not complaining, we had some good stuff, but. So this is a little video that's going to show the last deglaciation. So I just like this one. This is fun. So we started 21,000 years and it shows, and you'll see, you know, it's going to recede, it's going to advance again, and we're going to recede and advance. We have these recessions and these advancements throughout our ice age. The ice isn't ever kind of standing still, it's always moving. And eventually, about 507,000 years, all of the ice has actually left Hudson Bay area, and Hudson Bay is now free of ice. To this day, though, with that ice pack, with that glaciation being concentrated over the Hudson Bay, there was so much weight and pressure on Hudson Bay that the land there was so depressed and compressed that to this day, it is still rebounding from the depression that it was facing. And they call that isostatic rebound. Okay, so again, I grew up where there was a lot of till. You don't have to say glacial till. Till infers that it's glacial. It is unstratified mixture of rock fragments of all sizes, and it's directly deposited by the ice. But we also have what they call a glacial drift. This is just the general term for everything that's deposited by the ice. Just a general term. If you don't know, you just say, that's glacial drift. Stratified drift, this is just kind of going to be your glacial drift, but it's going to be stratified. It's going to be sorted. Stratified means sorted. Your sands are going to be together, your clays and your silts are going to be together. Here's a good example of what a till looks like. This till comes from New York. No, just a mix. You can see it's sand, it's silt, we got cobbles in there, all sorts of good stuff. So here's a figure just to show as the ice is receding, what gets left behind right away, we end up with these ice blocks left behind. We have some ice dam lakes, meltwater coming out. And then when the ice is gone, that's when we're going to see these landforms that we can still see to this day. So again, these are the landforms from continental glaciers. So these are the ones we can find hiding under the Laurentide ice sheet. First one, this is an esker. This is a narrow, often sinuous embankment of coarse gravel boulders deposited in the bed of meltwater stream in a tunnel within stagnant ice. So this is actually a river flowing under the ice that is depositing gravel and rocks and debris as it goes. And you end up with these sinuous lines that we call eskers. Sinuous, let's see. When I say that, it's sinuosity. Think of a river. If a river is straight compared to a river that is meandering around, the meandering river is going to have a greater sinuosity than the straight river. That's the way to think of sinuosity. Next, you're going to have a drumlin. This is a smoothly rounded oval hill of glacial till deposited formed by moving ice. These are great because these tell you which direction that the ice was flowing. So what happens as the ice is coming along, so the ice is coming from left to right, and what you have is you have a bedrock. The same thing happens in your streams. If there's a stone just laying in the middle of your stream, as the water's flowing, and let's say some sand is flowing along with that water because it's real turbulent at that point, that sand's going to catch on that rock and start building around and depositing around that rock. The same thing's happening with this drumlin as the ice is going over it. And opposite of that, and very fun to say, is the Roche Montagnais, and it is a rock formation created by the passing of a glacier over bedrock. So instead of having the debris get caught, this time the direction of ice is coming up over the bedrock and it's plucking the bedrock away on the lee side. So another great landform that tells us which direction the ice was going. And then we have cams. These are steep-sided mounds of stratified sand and gravel. Again, keyword there, stratified. And they're usually deposited at that terminus of a glacier. So again, the greatest extent that the glacier went is where you're going to find your cams. And outwash plain, we've talked about it a little bit already. These are formed from stratified drift left by streams discharging from the ice. So that's kind of like the glacier just kind of going blah at you. Another great picture of some till too. Kettle. This is a depression or hole in an outwash plain formed by a retreating glacier. It's formed as a result of blocks of dead ice. So in that little figure that I saw, there's an ice block sitting there. Well, that ice block kind of depressed the land, and after it melted away, we're left with these little depressions. And erratics. I have been to this. This is incredible. An erratic is a glacially deposited rock differing from size and type of rock native to the area in which it rests. So not native means it was moved there from somewhere. This is Madison Boulder. This is 5,000 tons. It is made up of Conway granite, and Conway granite is not the local bedrock. The local bedrock is Concord granite. So it was transported about 2 miles south to its current location. So again, how powerful is ice that it picks this up and just moves it? And I'm telling you, it probably did it effortlessly. So let's talk glaciers and climate change. Nope, I'm not doing this type of climate change. Let's talk long-term climate change, because when it comes to glaciers and the way that it interacts with our climate, that's what it is. It's more of a long-term thing. So an ice age, first we're going to talk about what an ice age is. I'm just going to take a drink real fast. I took lots of vitamin C today. An ice age is a geological period that lasts millions of years. So today we're living in the Quaternary period, and it is an ice age that began about 2.6 million years ago. And a glacial period is a very cold stretch during an ice age when the ice sheet spread out from the poles. The last glacial period was the Pleistocene epoch, about 2.6 million years ago to 11,700 years ago. So what we are in is an interglacial period, and that's when most of the ice retreats back to the poles. Greenland and Antarctica are those today, and we still have glaciers in some of our highest mountain areas. So we are technically still in the Holocene epoch. We have had scientists try to come and say, hey, it's time to say that humans are making an impact. We need to change to an Anthropocene epic, but that was denied. So we're going to stay in the Holocene for now. So just to review, we're in the Quaternary period. That's the 2.5 million to the present. We undergo 4 glaciation periods during this time, and all species unable to adapt to the cold or heat become extinct. We lose our dire wolves, our saber-toothed cats, our giant sloths. We know this. We lose our mammoths. We are currently in the Holocene epoch, which started 11,700 years ago. And this marks the end of the last ice age. Sea levels rose about 45 meters, and the Great Lakes formed. This is just another thing to kind of show you that we're not just going from glacial to boom to this. We're going in and out of these periods all the time. I got to think on a geological time too. And I wouldn't be doing justice if I didn't mention abrupt climate change, because it is possible. I want to stress the importance of these long-term cycles, but abrupt climate change can definitely be a thing. It does occur when a climate system crosses a threshold. It's just like when the pressure is building up on the rocks and all of a sudden our plate boundaries snap and we have our earthquakes. The same thing can happen. The Earth's environment is a fragile thing, and we are fortunate enough now to live in a stable time. And an example of this is the Younger Dryas that Andrew was talking about in his video. It's named for a flowering plant, Dryas. At this time, Greenland temperatures dropped as low as 15 degrees below modern temperatures. So time of cold period, Andrew talks about, I wasn't going to go into this, but the other theory is what they call a North Atlantic freshening. So the idea is that Lake Agassiz, part of the Laurentine ice sheet, all of a sudden had this great outburst of fresh water, and that fresh water capped the sea, the ocean water, which allowed which stopped the phthalo. See, you didn't give me a chance to like review everything. It capped, and the thermohaline flow in the ocean was capped off. So the warm water was not able to rise to the surface. So that's another idea for what caused the Younger Dryas. And again, it's not conclusive. There's more than just those 2 theories too. So I do want to mention that when I say calendar year before present, this means 1950, and this is used as a reference because it marks the start of the practical radiocarbon dating that was first published. So that's where 1950 comes from. Another abrupt climate event is known as the 8.2 Ka event, and this was a period of rapid cooling during a warm period. So you can take this Younger Dryas period, which was kind of a big hit, and say it was about half the magnitude of that. So Greenland temperatures only dropped from 4 to 8 degrees Celsius. And here's some of that proxy data that supports this evidence of this 8.2 Ka event cooling period. You can see all of these happen to fall about 8.2 Ka. This comes from a study by Richard B. Alley from 2005. He is a professor at Penn State, and he has done some incredible studies. And if you want to talk to somebody about how difficult it is to work on Greenland and core the ice in Greenland, he'd be the man to talk to. It is not a job for the lighthearted. I'm not going to do it. We'll put it that way. Here's another kind of indicator. Atmospheric CO2 dropped 25 parts per million in Denmark during this 8.2 Ka event. So this is just a couple different proxies that are used to determine what happens in climate change. So other ones, you've probably heard of the Little Ice Age and the Medieval Warm Period, the Roman Warm Period. These are all just periods of climate fluctuations where we have, instead of things happening over geological time of hundreds of thousands of years, they're happening in these short decades type periods. So these are not things that are not uncommon. It's common for this to happen. This comes from my work. And this is Stony Lake is a lake on Lake Michigan. And you can see that my oxygen isotope data here, I got this huge shift over here. And this indicates this warm dry burst that happened at 6,600 years in this area. It doesn't mean that this is global. This is local to this area. But as you can see, I was studying ostracods and gastropods and how they related to climate change. This Valvata sincera, this is a cold water gastropod. So very big indicator species there. So we can go over all of these possible causes of ice age. We have them talking about the motions of tectonic plates, the volcanic activity that produce dust that blocks solar radiation, decrease in the sun's energy output, change in atmospheric composition, reduction in greenhouse gases. So what do a lot of these have in common? They kind of have things to do with like solar radiation and sun's energy, greenhouse gases. Well, here's the theory that I like and the one that's most accepted, and that's the astronomical hypothesis. This is the explanation for glaciations and interglaciations based on these variations of solar energy being received. And this is by Milankovitch. He was a Serbian geophysicist and astronomer, and they're called the Milankovitch cycles. And there's 3 of them. In 1920, he hypothesized that variations in eccentricity, axial tilt, and precession of the Earth resulted in variations in solar radiation. And this is what influenced our climate patterns on Earth. So here's our 3 cycles that Milankovitch talks about: eccentricity, precession, and axial tilt or obliquity. And we're going to go over each one of these individually because I assume maybe this is new for a lot of people. So the orbital eccentricity, this is how far a body deviates from a perfect circle as it's orbiting. So currently, I'm just going to go to this because it's so much easier to do it this way. So here we go. This is the easiest way to do it. So every 100,000 years, we're going from near perfect circle to this more oblique. So in 50,000 years later, we're out. So that is what eccentricity is. Sometimes we're closer to the sun. Sometimes we're further away from the sun. Axial tilt or obliquity. This is where the planet's vertical axis is tilted. This one's a little simpler. It's just kind of like how's the Earth tilting. This is likely a factor in long-term climate change, especially when combined with precession. This strongly influences our seasons, and this is on a 41,000 year cycle. Okay. No, doesn't seem like much, does it? It surprisingly will cause significant changes to our climate. Just this little bit of a tilt. And the third one, precession, this is our wobble, how we're wobbling. And this happens every 26,000 years. So every 72 years, we're at a 1% degree different in our cycle. So, you know, when you're young and your grandparents are telling you that the sun's just hotter than it used to be, they're actually not wrong. So here's what a wobble looks like. So think about it. We're doing all 3 of these cycles, right? We're rotating from a perfect circle out to a more oblique shape, I guess. We're wobbling, we're tilting. So let's look at this. 100,000 years, we're on a cycle. Precision, let's times that by 4 to try to get to 100,000. That's going to be 104. 41,000, let's times that by 2 to kind of get to our 100,000 because they're saying these glacial cycles, you know, they're happening like every 100,000 years, right? Well, here we go. Put all these cycles together and you get 95.3. So it's not every 100,000 years, it's more like every 95,000 years these cycles are meeting up. So there you go. Eccentricity, obliquity, and precession all will eventually line up together. So kind of what does this all mean? Where are we in these cycles? Our eccentricity, we are actually near circle, like near circular. We're closer to the sun than we usually are. We get a 6% difference in solar energy from January to July. Today, our tilt is about 23.4 degrees, about halfway between the extremes, which accounts for our seasons. With less axial tilt, the sun's solar radiation is more evenly distributed between winter and summer. So we're looking good, right? Axial precision makes seasonal contrast more extreme in one hemisphere and less extreme in the other. So again, in the northern hemisphere, yeah, we got it kind of good. You'd think like our weather is so crazy, but this is actually pretty great compared to what we could have. Because the southern hemisphere, they're having hotter summers than they would be having if precession was tilted the other way. If precession was tilted the other way, as it will be in about 13,000 years, things are going to look a lot different for us up in the northern hemisphere. So where are we going? We don't need to really worry about it because we're not going to be here. But in approximately 45,000 years, the orbit will be at its most elliptical. So the energy reaching Earth is going to be 20 to 30% greater than it is today. The axial tilt, we're headed in the direction of minimum tilt, meaning the solar radiation will be more evenly distributed. And again, southern and northern hemispheres are going to switch in about 13,000 years. All righty. That was it.
Well, thank you.
I know I talk really fast, so.
Yeah, that was a lot to digest in a short amount of time. However, this is being recorded, so you all can check it out again and go back through everything. Uh, she's taught me so much about all this over the years, and I've spent a lot of time in Maine myself, growing up. So this has helped me understand the surroundings of where I was growing up and the lake that I was on and stuff like that, and some of the massive boulders that are there. So thank you, Brittany.
Yeah, landforms are all around you.
Yeah. I'm not seeing, does anyone have any questions for her? I don't see any yet. But I figured, it's just fitting that we have 8 inches of snow on the ground right now throughout Pennsylvania and even down here in Baltimore too. We still have quite a bit. They've been removing it all with excavators and stuff. All right. Well, thank you very much. That was amazing.
Thanks for having me.
Absolutely. Thanks. So we'll keep our eye
Jennifer, by the way.
We'll keep our eye on the chat, but let's go ahead and do the giveaway for the 2 crystals. Let me pull up. I really did not like the Google random number generator, so
what the heck is that?
I went to random.org this time. So you all are seeing this. So over here, true random number generator.
I didn't enter.
Oh, go ahead. Throw it in there real quick. Everyone get it in real quick.
What if I repeat? I'm just going to do that.
All right. So you got yours in. All right. Dan, Renee, you all just got in under the wire here. All right. Cool. I'm going to go ahead and hit generate. It's between 1 and 350. Here we go, everybody. Result 201. I'm going to stop sharing so I can see what we're doing here. So 201. Who won? Who's the closest without going over?
Oh my gosh, it's me.
Is it?
No.
Oh, you're 2.
At our Christmas holiday party this year, I had scratch offs in my white elf and I pretended I won $500. It didn't go over well with everybody.
I'm seeing Michelle H. Michelle H. Are you here? I think it's you. 191. Yeah. All right. Michelle H. Can you unmute yourself and just tell me who you are, what your last name is, so I can send you?
Should put it in the chat. Yeah, congratulations.
Thank
congratulations.
You. That's so cool.
Awesome. So what is your last? Oh, Harner. Okay. I got you. I will send that out soon. Don't kill me if it's not right away, but it will go out as soon as I can get it out.
No worries. Thanks again.
So congratulations. We are going to give out, we are going to do these giveaways at least for the next few months, leading up to Memorial Day, and probably after that, because I've got quite a few ready to go, over a dozen, and more on the way, actually. Because I've been on pretty much every Friday night, I've been on the Area 51 Miners. If anyone hasn't checked it out on Instagram, the Area 51 Miners Boutique, I believe it's called, or look them up. But every Friday night they have auctions, and sometimes things just go real cheap. So I just throw a $5 bid and I get some awesome stuff. So, these were part of a lot. And they also sent us a bunch of free crystals too. So that's why we're going to have so many. So, Shane's great. So, all right. Congratulations, Michelle Harner. And thank you, Brittany. That was amazing. Does anyone have any questions? I don't see anything. So, yeah. Anyone have anything they'd like to share real quick at the end here before I end the meeting?
Yeah, I'd like to
Dan.
say something. Now, I'm very happy that they're using 1950 as a present date. That's the year I was born. I feel like I'm getting on there like BC.
Heck yeah.
Yeah, you are the
Very good.
standard.
All right.
All right.
Hey,
Thank you, Dan.
Thanks for having me, everybody. That was fun. I love giving that talk. And I know I talk too fast. Sometimes you gotta stop me.
Oh, good. All right. Well, I will get this posted and I'll send a link out to everyone in the next day or two, depending on how long it takes me to get it all together and out. So yeah, thank you, everyone. We will see you March 10th, I believe. It's always the second Tuesday on the month. So we will be here with Ryan Klockner next month. And I'm hoping Shane and Sherry Moore from Area 51 Miners, they will be here to tell us all about Area 52 and maybe 53 and 54 if they want to tell us more. I'm hoping they're going to have some crystals to show off too. So if they can attend, they're not sure if they can be here, but oh yeah. That was supposed to be tonight too, wasn't it? I forgot all about that. Okay, everyone. The scholarship. We were supposed to pick a scholarship winner for those who signed up for the scholarship drawing. I apologize. I had completely spaced out on that. This is to be submitted to the EFMLS as for the winner. There's a drawing at the EFMLS level. We pick one member from our club to be submitted to them. They pick it to get a scholarship to Wild Acres. So give me 1 second. Let me see if we can even do this real quick. We only had one response we only had one person enter. So they officially win, I guess.
I made it easy.
Yeah. All right. Cool. That takes care of that. And I'm not sure who this is, so I'll have to contact them to find out who it actually is because I only have an email address.
Oh, I think Deb asked what Wild Acres is. You should send a nice email
So this was all
out for everybody because it's an incredible experience.
Yes. So this was in the newsletter. EFMLS puts on every year a week down in North Carolina. It's based on lapidary and jewelry making and stuff like that. Basically, it's an all-inclusive resort. It's only $525 for the week. You get food, you get board, you get all that. But then you take classes all week and you get to select from a list of classes. Some of these classes do have an extra fee for materials. If you're going to do wire wrapping with silver, you got to pay for it, stuff like that, gemstones, that kind of thing. So, and then they also have, a raffle down there. So people bring some really cool things, but it's in the mountains of North Carolina. EFMLS actually donated money last year during that hurricane that destroyed a lot of things because their road got wiped out and stuff like that. So great place, great time. If you want to see more and learn more about it, go to efmls.org. There's a whole web page about Wild Acres and learn more about the EFMLS. I'm the president. Sylvia, who is the treasurer of Geology Club, is also the EFMLS treasurer. Tina, who is leader of Geology Club, is also the secretary for EFMLS. So we're tied in quite a lot. Brittany's been involved before, I believe, with the EFMLS at some point. I think you were Region 3 VP. I took over for that. I'm now
For a
Region
little
3
bit.
VP. So yeah, anyway, check it out. I am looking for people to join the EFMLS team. So if you want to step up, we have plenty of committees, plenty of things that you could do at the EFMLS level. Just reach out to me. I will throw something at you real quick. So, and welcome to the team. So anyway, thank you all very much. We are going to submit whoever the one person was that signed up for the scholarship to be sent on to the EFMLS, and that will be picked in March, I believe, by the EFMLS Wild Acres team. So there's a whole team that puts the Wild Acres together, and they're gonna pick that. So you can see more in the EFMLS newsletter, which I'm going to start sending around here with our new newsletter. So also keep on the lookout for our monthly newsletter that Joanna is doing for us. Thank God, because everyone knows I can't do newsletters. Brittany, I failed at the Central PA one for a month, so before Renee took over. So thank you all, and keep your eye out for that. And hopefully we'll be sending EFMLS newsletters at the same time, so you can check those out as well. All right, and with that, thank you all for being here, and I'll send this link out soon, and we'll see you next month.
All right, thanks again for having me. See ya.
Thank you. Thank you, everybody.